So today I'll talk about insertion sort. Now what is insertion sort? Well, it is one of many methods to sort things. For example, let's say we have an integer array called array A. And in this array, the integers are not in particular order. And let's say I want to sort the array from the smallest to the greatest by using insertion sort. So what insertion sort does is that it divides the array into two categories, the sorted side and the unsorted side. Now the reason why the divider, the blue thing, starts here instead of the beginning of the array is because 65 is the only integer on the sorted side, therefore it is already in the correct position, so we don't have to touch it. Now let's sort the next integer. What insertion sort does is that it compares the unsorted integer to the sorted integer to see which one is greater. And in this case, 65 is greater, so it will switch position with 3, and since 3 is now at the beginning of this array, this means that the sort is complete. And now we move to the next integer. 45 is less than 65, so 65 will move one space to the right, and 45 is greater than 3, therefore 45 is inserted between 3 and 65. And now we move to the next integer. 50 is less than 65 but greater than 45, so it will be inserted between 45 and 65. Now here, 77 is greater than 65. This means that it is already in order, so therefore we don't have to change its position, and it automatically becomes sorted. Now moving to the next integer. 14 is less than 77, so 77 is moved one space to the right. And 14 is less than 65, so 65 will move one space to the right. 14 is less than 50, so 50 will move one space to the right. 14 is also less than 45, so 45 will move one space to the right. However, 14 is greater than 3, therefore 14 is inserted between 3 and 45. Now the same thing happens in the next integer. 34 is less than 77, so 77 will move one space to the right. And 34 is less than 65, so 65 will move one space to the right. 34 is less than 50, so 50 will move one space to the right. 34 is also less than 45, so 45 will move one space to the right. However, 34 is greater than 14, so 34 will be inserted between 14 and 34. Now that we've reached the end of this array, this means that the array is now sorted. Now let us look at the pseudocode for insertion sort. On line 1, it basically sets the parameter of the divider, that is the blue line that divides the sorted side with the unsorted side. And what this code says is that the divider starts at array A1, which in other words the second integer in the array. On line 3 and 4, we're keeping track of our current position in the unsorted side. On line 6, we are comparing the value of element, which is the current value that we're trying to sort, with the value to its right side. This loop will end once the element is greater than the value to its right side. On line 8, we're shifting each value that we've compared that are greater than the current element. This opens up a space so we can later insert the element once we found the location where the element is greater than the comparing value. On line 9, we are updating the counter to continue to move left through the sorted side. And on line 12, we're inserting the element to the sorted side of the list. Note that it is alright to insert into a square bracket j because we already moved the value that used to be there one space to the right on line 8. Now remember that we're moving from the sorted portion from left to right. This implies that we're moving from the unsorted portion from right to left. Now let's look at the runtime of insertion sort. Because it is a loop inside another loop and both loops are counting by adding or subtracting, therefore this means that in the worst case scenario, insertion sort has the big O value of n squared. But let's say you run insertion sort through an already sorted list. This means you only have to perform one comparison per value, therefore in the best case scenario it will perform n steps, and we represent this by using omega of n. There are many applications for sorting. For example, in business, sorting allows you to rank your product sales so you can figure out which product sells the best. And there are many more other practical uses for sorting, but the real question is why should you use insertion sort? I mean, there are many other ways to sort an array, and many of them performs better than insertion sort. Well, the reason being that insertion sort is one of the easiest sorting methods to understand, and for small values of n, insertion sort works just as well as others. And there you have it. That was insertion sort.